Now let's talk about approving a there exists statement and using a there exists statement. Again, these processes are going to look different. Just like proving a for all and using a for all looked different, just like proving if then and using an if then looked different. So to use, there's not really a lot to do other than just if you come across this kind of sentence and how can you get something from it, really you just want to make sure that X hasn't been used yet. Um, if you could be in the situation where you want to use a statement but X has already been used for something else, like the X that appears here and here, it's really a variable. So if X has already been written as part of your proof, then instead just switch all the variable X's to Y's here. Then you have like there exists y in S such that P of y instead. So let's just go to the case where you could rightly just say there exists X in S such that P of X. If you can do that, then from this point on in your proof, you have a thing in your proof called X, and it is defined. And what you know about X is that you know that X is in S, and then you know that P of X is true. So pretty straightforward. If instead you had been doing this where you had to use an alternative letter, then same kind of deal, right? If you had to write, so there exists a y in S such that P of y, then you have now a y that's available in your proof, and you know that y is in S, and you know P of y is true. So that's using a there exists. How about proving there exists X in S such that P of X? Now again, let's just assume that X has not been used yet in your proof. Then you have to define something to be called X, or you could use a different letter even if X has not been used. You could use a different letter, but let's just, for the sake of writing this, let's just say we're going to define something, call it X, and then you should, based on how you define X, prove that X is in S, right? Because you need there exists not just X, but an X that's in S, right? And then the other thing to do is prove P of X. And I should just comment that you can prove either of these two things in either order, whatever order is convenient for you, but you should prove those things. Sometimes the X in S part, or whatever the set is, sometimes that doesn't require a whole lot to say. So sometimes in some cases you'll kind of get used to this in class, the context of it, what are the standards. Sometimes you get to skip this, but based on how you define X, it really must be true, right? For instance, maybe you have to prove that X is in, Z, the set of integers. And maybe because you defined X here to be the sum of two integers, maybe it's going to just be too much to always say stuff like, oh, since the sum of an integer and another integer is results in an integer, therefore X is in Z. Maybe you don't have to get down to that level of detail, right? Um, People do find this step the hardest, and it's because you have to define something and then you have to do two other things, these two mini proofs after. So I'll just say it can be challenging to define X to be something, right? Like you have to pick something specific and say X should be this, right? And that can be hard to do. People kind of note that amongst, proving a for all, using a for all, proving a there exists, using a there exists, amongst those four very typical things that happen, this proving a there exists is usually what people consider the hardest, understandably so, because you've got to define something, and people, I think, run into this thing where they say, I have no idea how I'm supposed to do this, right? And it's easy for me to say, well, the only thing that's useful to say, or sorry, the only thing that's true to say is, well, it's problem specific. And that's true, but then it doesn't feel very useful. So, how about a real helpful tip is to say, you got to define X to be something specific, sure, but then use the fact that X is going to have to be in the set S as a hint, right? And what that's going to mean is you're going to need to ask yourself, well, what kind of things belong to the set S anyway? Maybe S is a set of integers. So if you're proving there exists X in set of integers, then you're gonna right away that you have to define X to be an integer. And so then you kind of want to look amongst all the integers you've already established in your problem, or maybe you just have to pick an integer outright. Let X equal 3. Um, so you should ask yourself what kind of thing you have. I mean, maybe your set S is a set of real numbers. Maybe it's a set of vectors. Maybe it's a set of matrices. Maybe it's a set of integers which are powers of 10 only. So use what S is as a hint to how you should define X.